All right, so we're talking about quartiles, interquartile range, semi-interquartile range. These are what we call measures of dispersion. Now, quartiles basically divides the entire ordered data set. So if it's placed into either ascending order, usually you go with ascending, it divides it into 4 equal parts. The median, which we have seen before, is the middle of the entire data, or we are looking at 50% of the data. 50% of the data lies below the median, right? The Q1 value, which is referred to as your lower quartile, looks at 25% of the data below or below 25% of this value. And the upper quartile is 75% of the data, and it lies below this value. Now, why is this important? You see, quartiles help us to measure the spread. How is the data that we have collected spreads? How does it look in terms of where our mean is, where the median of the data is? How is it surrounded around all of these things? It also identifies outer layers, meaning like what is the highest value and the lowest value and how the data is arranged in between these two values, right? Now, what you will be able, or what you will need to do is to be able to find the quartiles of group data using sometimes the formulas that we're going to go through here, and at other times you're going to be using your cumulative frequency curve, which we'll look at another time, right? So we're going to look at finding the quartiles for group data. Now, the first thing you need to do when you have to find the quartiles is to ensure that the data is arranged, right? And you would use the cumulative frequency in order to find different positions. Now, N is your total frequency. In all of these formulas here, N is looking at the total frequency. So in our previous example, we looked at finding the total of our frequency column, right? This N value is the sum of all your frequencies. Now, to find your Q1, Q2, and Q3 values, Q1 being your lower quartile, Q2 being your median, and Q3 being your middle quartile, we are basically finding for Q1, 25% is a quarter of all the values. So we divide the total cumulative frequency or the total frequency by 4. To find the median, we divide it by 2. We find the half, 50%. And to find Q3, we find in 3/4 of that. Now, remember we're using intervals. So you have to identify the class containing each quartile, right? Now, after you identify the class containing each quartile, we could use this particular formula in order to work out what that particular value is. Now, let's look at an example so you'll better understand what we just spoke about here. Now, this is group data from our previous example that we looked at. We have 1, 2, 3, 4 class intervals. These are the frequencies here. And this is my cumulative frequency. My cumulative frequency will always sum to the total of my frequency. So if I add 4, 7, 5, and 4 here, my total frequency will be 20. So that is the number or the figure that we represent as being N, my total frequency. Now, let's say we want to find our Q1 value. The first thing we're doing is finding the position. This is not the actual value, but rather the position. So we take our total frequency, we divide it by 4. So 20 divided by 4 is 5. That gives us the position of where my Q1 value will be, right? So it means that my Q1 position is in the 5th position or 5th spot. The 5th spot, if you look at the cumulative frequency here, up until here, we only have 4 spots. The 5th position or 5th spot will actually fall in this particular class, right? Because up until this point, we have 11 values or 11 observations, right? Now we're going to do this for Q2 and Q3. Q2, we divide in our total frequency 20 by 2. That'll give us 10. We already calculated the median in another question. The Q3 value is going to be 3/4 of that 20. So N divided by 4, that's 5. 5 by 3 is going to give me 15. Now these numbers that I have here are not actual data values. They're not observations. What these are positions, right? These are positions in the order data. So after we identify the positions, we want to locate now the quartile class. So my Q1 position 5 falls in this class 5 to 9. How could I tell? Because up until this point, let's just say in this interval, we have the frequency being 4. So there are 4 observations that belongs to this class. That could be 4 zeros. It could be 2 zeros or 1 or 2. It could be a 1 or 2 or 1 or 3. That's 4 observations. We don't know what the exact numbers are. All we know is that the frequency of data observed in the interval 0 to 4 is 4. So that's just 4 positions. So what I'm saying is that the 5th position will have to be in this class interval because we are only going to get to the 5th position when we get to this class. Right? Similarly, the 15th position is going to fall in this class. Right? So this here is my 5th position, and here my 15th position will be in this class. So I am identifying the class that these positions will fall in. After we have identified the class that they fall in, then we could apply the formula. Right? Now the formula, let's just go back to the formula, takes our lower class boundary. It adds the position, so that's what we calculated, the 5th and the 15th position, minus the cumulative frequency before the quartile class. Very important. Frequency before the quartile class. And then we divide that by the frequency of the quartile class and multiply by the width. So let's go take a look at that. So for my Q1 value, the lower boundary would have been 4.5, right? Because we're looking at the class 5 to 9. The cumulative frequency of the class before that was actually 4. We saw that here. This is the cumulative frequency of the class before. The frequency of the current class is 7, and my class width is 5. That's where we're obtaining the values from. So my formula, L plus the L is my lower class boundary, right? We're going to go with our position, the 5th position, right? This was the value of n over 4 minus what my cumulative frequency of the class before over the current frequency multiplied by the width. This is my Q1 formula. My Q3 formula would have been the same lower class boundary. The difference here is that we would have worked out the position for Q3, which was 3/4 of n, minus the cumulative frequency of the class before, right? The Q3 class or the class identified, divided by the frequency of that particular class that we calculated for our 15th position multiplied by the width. Right? So Q1, we have 4.5, cumulative frequency being 4, the position being 5, the frequency of that particular class being 7 by our class width. That works out to be approximately 5.2. My Q3 value, 9.5, is my lower class boundary. The 15th position minus 11, 11 being the cumulative frequency of the class before that Q3 class that we identified, divided by the frequency of the current class by my class width. That works out to be 13.5. Yeah? Now, let's talk about the interquartile range and the semi-interquartile range. The interquartile range is the spread of the middle 50% of the data. So if we have data like this, and let's say this here is my Q1 value. This is 25%. And then here now, this is my Q3 value. This is 75%. In between here is where my interquartile range is. It's looking at the middle 50% of data, right? To find this value, we are simply subtracting my Q3 minus my Q1 value. So the Q3 was 13.5 and our Q1 was 5.21. The difference between these two is how we find the interquartile range. Very easy. Nothing difficult to do. The semi-interquartile range, we will take that same figure that we got for interquartile range and we will just divide that by 2. Right? Now, this is useful for comparing the spread between different data sets. It looks at how the data is spread in different positions of the entire data or population that you are observing. So let's try a practice question now. Right? Using the table below, we want to calculate Q1, Q3, the interquartile range, and the semi-interquartile range. I'm going to write a formula just so that you remember how to work it. Q1 is going to be the lower class boundary plus on top we have n over 4 minus the cumulative frequency of the class before over the frequency of the class that you have identified as a Q1 class multiplied by a width. Q3, similar. The only difference is that we're going to have 3/4 n, right, minus the same cumulative frequency over our frequency multiplied by the width. The interquartile range will be found by taking your Q3 value and minus the Q1 value from it. And the semi-interquartile range will be found by dividing your interquartile range by 2. So you're going to try that for me now. All right, so you're going to correct the question now we're looking at where we need to find our Q1, Q3, interquartile range and semi-interquartile range. So the first step, step 1, is to find the positions. Now to get the positions for Q1 and Q3, we'll be taking n divided by 4, and here you're finding 3/4 of n. Now n is going to be the total of your cumulative frequency or the total of your frequencies, which is 15. Now what that means for us here is that if we do 15 divided by 4, we didn't get a whole number, we'll get 3. 3 4s are 12, and you remain with 3/4. Now, because this is a position, you don't have a 3 3/4 position, so you're going to round it up. So this is approximately the 4th position. So you're going to look at where your 4th position would lie. So your Q1 position will be here, right? Up to this point, when you have 3 values, the 4th value will be in this particular class. So this is my Q1 class. Now, for my Q3 class, we're doing the same thing, 3 by 15 over 4, which is 45 over 4. And this will be 11 1/4. Again, this will have to be, we don't have a 11 1/4 position. We passed 11, so we're going to round up to the 12th position. So that means my Q3 position will lie in this class, right? So we have identified our classes. Right, we're gonna identify the classes, and we're gonna find the values now. So formulas, pulling out my formula for Q1, L plus N over 4 minus the cumulative frequency over F multiplied by the class width. For Q1, my L is going to be 5 is my lower limit minus 0.5. So that's going to be 4.5. Right? N over 4 is going to be the 4th position. Our cumulative frequency of the class before the model class will be 3. The frequency of this particular class is 5. And my class width, 9 take away 4 is 4 plus 1 is 5. So for my Q1, it's going to be 4.5. I'm pulling these figures from here, right? Plus 4 minus 3, cumulative frequency 5, multiplied by my width of 5. So again, 4.5 plus 1 over 5 by 5. So that's 4.5 plus 1 5.5. So that's my Q1 value. All right, let's do Q3. Q3, the formula is L plus 3/4 N minus the cumulative frequency over F multiplied by W. My values now. My lower class boundary of the Q3 class will be 10 take away 0.5, right? We're looking at these values here. That's my lower limit. So my lower boundary, we're going to put lower class boundary just to be clear here. It's going to be 10 minus 0.5. That's 9.5. My 3/4 N, we say would be the 12th position, the cumulative frequency of the class before. So the class before would have been here. This is my CF value, and this is my F value. So CF is equal to 8, and F is equal to 4. Right? And my class width is equal to my upper class limit minus my lower class limit plus 1. So we're talking about here 14 take away 10 plus 1. 4 plus 1, which is equal to 5. So let's drop some values inside the formula. 9.5 plus, we say we're using 12, 8, frequency is 4, multiplied by 5. 9.5 plus 12, take away 8 is 4 over 4, multiplied by 5. That is 9.5 plus 4 over 4 is 1. 5 will give us 5. So 9.5 plus 5, that's going to be 14.5. So my Q1 values was 5.5. And my Q3 value was 14.5. So next, I'm going to find the interquartile range, which is Q3 minus Q1. Q3 is 14.5. Q1 is 5.5. Right? If we subtract there, we're going to get 9. Right? My semi-interquartile range now is found by taking my interquartile range and dividing it by 2. 9 divided by 2, you get 4.5. And that's our solution for the entire question there. Yeah?